Welcome to Around Space. I'm Kent Miller. Today we're talking about the New Horizons mission to Pluto. I'm delighted to have with us Dr. Bradford Behr, astronomer and optical engineer. In 1992, he got his bachelor's in astronomy from Williams College in Massachusetts. In 2000, he got his PhD in astrophysics from Caltech. He then joined the McDonald University, Observatory in Texas. In 2003, he then joined the U.S. Naval Observatory here in Washington, D.C. In 2007, he then joined the private sector, bringing astronomical instrumentation down to Earth. Welcome back to this table.
Thank you, Kent. Great to be here.
All right, last time we talked about the mission and the instruments and so on.
Right, the history leading up to the launch of this probe to get a closer view of Pluto, to turn it from a little spot of light in the sky into an actual world with some detailed understanding of what it looks like and what's going on there.
All right. Now, I guess the story begins a few months ahead of the actual flyby. Pluto starts becoming more than a little dot.
In the cameras on board the on board the spacecraft, and we talked about the suite of instruments, the 7 different devices, each with their assigned role. So LORRI, the long-range telephoto lens camera, was presumably the first one to get pointed at Pluto, not just the dwarf planet itself, but they were particularly interested in what's surrounding it. There were at that point 5 known planets, 5 known moons of Pluto. 1 big one and 4 little ones. But as they were sending the spacecraft through the system at very close range, they were, of course, concerned there might be something else that we hadn't seen that the spacecraft would run into, and that would be very unfortunate. So
a risk mitigation investigation happened.
Some reconnaissance, getting the Hubble Space Telescope had been used for many years previously to try to find anything that's orbiting Pluto, and that's where 4 of these 5 moons had been discovered. But smaller objects, even though the onboard cameras are not nearly as big as Hubble, they're much closer, and so able to see faint or small things that might have escaped previous notice.
And as luck would have it, no extra moons.
didn't see anything worrisome. No narrow rings like are around Neptune and Uranus. As we know, as of late in the evening of July 14th earlier this year, the spacecraft made it through its flyby unscathed. And cheers erupted, and I'm sure a lot of big sighs of relief were sighed. Then the real fun, there were some measurements made as they got closer and closer.
Right. Now again, as a safety precaution, they collected some data before the flyby, so that as they're getting closer, and sent it back. This was called the fail-safe data set.
Right.
Now, this was insurance against what?
A catastrophe of any sort, either a collision with something that they didn't see, or things happen to space probes, even with all the hard work and expert engineering that goes into them. Sometimes a radio circuit will fail and we never hear from it again. So they wanted to make sure they had something to show for all of the millions of dollars and years of people's time that had been invested.
Yeah. Now, another thing I noticed is that this spacecraft doesn't seem to have any moving parts.
Right.
The cameras don't gimbal, right? You have to actually turn the whole spacecraft.
Right.
And that means your radio antenna is not pointing back at Earth.
Not right. All of the various cameras are at fixed positions on the bus, the body of the spacecraft.
So during the data collection, you're out of contact.
Exactly, right. and that made it extra nail-biting, I imagine, for everyone, especially the project team. So right, the weeks, if not months in advance, this whole sequence of data collection had been planned out in exquisite detail. Move the spacecraft in order to point one camera at where we're pretty sure Moon 3 is going to be and get a quick snapshot of that, and then pivot as we fly by Pluto itself and covering different parts of the surface. The point that a lot of our viewers, I'm sure, are well aware of, but bears repeating, is that Pluto is so far away, it takes the radio signal over 4 hours to get there. So there's no real-time control. There's no engineer moving a joystick to pan and tilt in real time. You have to know what you want to look at well in advance and then hit the autopilot.
So basically, scientists have to get together and say, all right, what's going to happen in what sequence?
Right.
And that has to be planned out second by second through the whole flyby.
Based on what you know from all the previous measurements, both the earlier Hubble measurements and these long-range reconnaissance. So I suspect they probably had a pretty good plan put together, even years in advance, but then based on late-breaking news, we can tweak it. There's another moon. Let's make sure we get a few extra shots of it going by.
Right. In fact, 2 moons were discovered on the way out.
Right, during the long cruise period of the mission while it was en route from Earth to Pluto.
All right. Let's talk about the data return. Now, of course, during the flyby, when you're tilting the craft this way and that, you can't return the data.
Right, that big radio dish that talks back to Earth might be pointing in any which way.
So it's really after the flyby, then the data starts coming back.
Right, point back at Earth and start downloading at a glacially slow rate by our modern standards. Now
I understand the maximum rate is 4,000 bits per second.
Right, not baud, not bytes per second, not kilobits, not megabits, not gigabits that we're used to from our broadband internet. This is pre-dial-up speeds, and the reason, of course, is that it's so far away. The radio signal from the spacecraft is so weak that you have to take it very slowly, practically a bit at a time, in order to get a decent measurement and be able to actually receive those bits accurately.
So now my understanding is that on the Earth end, we only have about 8 hours of time to allocate to
Right, the
Mars.
radio dishes on Earth that are receiving these signals,
because Earth rotates,
are not always in view of Pluto.
Right.
Furthermore, they have to be shared with all the other spacecraft that are out there. The so-called Deep Space Network is not dedicated exclusively to this Pluto mission. Has to be
so it's only about 8 hours a day.
Exactly.
Which is 100 megabits per second. But the total take from the experiment was 50 gigabits.
Right.
So that means
photos and spectra and radio data and the dust counter, all the other instruments we talked about in the previous show, each of them were furiously collecting data throughout the flyby, and now it's a matter of slowly sending
take
it
500 days
to get it all.
Oh dear.
So, and you had told me about a clever strategy that they're taking. First, they're compressing all that data, lossless or lossy. I'm not sure. Maybe a combination of each.
I don't know.
Our viewers, I'm sure, are familiar with JPEGs and MP3s, data formats that contain most of the information but squeezed down into 1/10 the size. So they're using that sort of algorithmic technology to send an advanced copy or a preview, if you will, of a lot of the most critical data. Actually, they're sending the entire data set compressed. Is that correct?
Yes.
Okay.
Yeah, and that'll take a few months, and then they'll resend the whole thing uncompressed, which will take over a year.
Right. So the scientists who've been eagerly waiting for 10 years for this data, in many cases have to wait even longer. There several snapshots have come back and initial data streams, and that's what we've seen in the press releases this month, this summer. But
even the sequence at which things get returned has been scheduled well in advance.
Scripted, exactly, based on what's most important to the most important people on the mission. What in particular, what information might be needed for the follow-on mission, which we'll talk about a little bit later on.
All right, so let's talk about the science. All right, now one of the things we really want is the geology.
Right.
And for that we need images, camera images.
Right.
So what have we seen so far?
Very unexpectedly, Pluto is an interesting place. Regardless of what side of the planet, is it a planet or is it not, debate you come down on, you got to admit Pluto is a world.
It's interesting.
Pluto is a big round ball with lots of different stuff going on its surface. There are towering mountains of 11,000 feet or more in height that are probably water ice, just based on what we think Pluto's made of and what the structures look like.
And at that temperature, ice is strong enough to stand up.
Rock solid.
Yeah,
we're about minus 400 Fahrenheit or 38 degrees Kelvin above absolute zero at the surface of Pluto. And so ice is a rock, or water, I should say. When we talk about ice, there are actually many different sorts of molecules that can turn into ice. So water ice is a rock.
You can build mountains out of it at that temperature.
At that temperature. But there are other substances like nitrogen and ammonia and methane, which are ice but not nearly as solid. And so another exciting initial result from these initial photos shows glaciers apparently flowing from one region to another. Flow patterns just like you'd see in Greenland or something.
What came in the news is this white heart-shaped region in the northern hemisphere, which appears to be a sea of perhaps nitrogen ice, and it looks like it's flowing.
Parts of it are flowing. It's concentrated in one large region of the surface. There are other regions that show a sort of reddish terrain that we think might be organic molecules that have condensed down out of the atmosphere. There are these mountains we talked about. There's a smaller patch of carbon monoxide, undoubtedly solid, that looks quite puzzling and interesting. There are just a wide variety of terrain and very few craters, which says that the surface is geologically active. Now, geo, of course, meaning Earth, is a little bit of a misnomer, but it's geology on another body. I won't say planet.
But we would have expected it to be heavily cratered. An ancient, heavily cratered surface, and it's not. It's
been sitting out there for 4.5 billion years. There's a lot of junk floating around the solar system, even that far out, so there would be impacts unless the surface gets reshaped, repaved. On Earth, we've got weather, we've got erosion. On Mars, there are huge dust storms that can obliterate or fill in a lot of craters, although many more are still present. But I think nearly everyone was expecting Pluto to be quite inert, nothing resurfacing it, and so it would be mostly craters. And there are a few craters, but there are also these ice fields that are probably 10 to 100 million years old, which sounds like a lot, but that's pretty young and fresh.
Don't have any craters.
Solar system standards. And the big moon, Charon, shows similar sort of topography.
Now, Charon is interesting. It looks more cratered than Pluto.
I hadn't picked up on that, but that's quite possible. And the part of the mystery is what's in order to keep these surface features moving around, there must be an energy source. It's not related to the orbit of Pluto and Charon the way.
Can't be. They're tidally locked, so they face each other the same all the time. So there's no flexing going on.
Right, the way there is in a lot of the moons of Jupiter that are spinning fairly rapidly, and so they are getting compressed like this on every rotation by Jupiter's gravity, and that keeps the ocean the probable ocean under the ice cap on Europa is kept liquid. Io has volcanoes shooting out every which way because of all the heat energy inside. Yeah. But that's not happening with Pluto and Charon.
It would suggest radioactive decay from the center,
exactly.
Real rocks,
real rocks,
silicaceous rocks,
which have a little bit of uranium left over from the formation of the solar system. As that decays, it releases heat.
Okay.
So that had not occurred to me earlier, but you had suggested that, and that sounds like a very plausible theory, but one that we'll have to investigate and test.
Yeah. Also, I noticed on Charon along the equator, it looked like a big crack, a canyon or something miles deep. So again, tectonics of some sort, some description seems to be happening, right. Which is all unexpected.
Indeed.
All right, let's talk about the atmosphere. This is what I really want.
Right, and this also was interesting and quite a surprise to the project scientists. We've known for decades that Pluto has an atmosphere. We've watched it pass in front of stars. Every several years or every decade, this happens by accident, and you can watch the brightness of the star drop off gradually over a few seconds, meaning there's a thin layer of something around Pluto. The
light signal is not extincted instantly. It's not a square wave.
Right.
It's a slope.
Exactly.
Okay.
So they knew there was an atmosphere there, and a lot of the instruments, the sensors on board the spacecraft were there specifically to make measurements of various sorts. But what came as a surprise, both from the measurements from the side and particularly sending the spacecraft through the shadow behind both Pluto and Charon, they were able to take a snapshot of the whole thing lit up like a halo. And it makes it look like the atmosphere is really big and really thick. I believe there were even some initial measurements as to the composition. And it's quite a mixture. There's a haze layer, like Los Angeles, down at relatively low altitudes, and then a lot of, was it nitrogen boiling off and surrounding essentially boiling away from the planet's surface.
I think it's being slowly stripped away by the solar wind.
Right.
So Pluto seems to have this tail of nitrogen that's being swept away.
Right, much like a comet's tail. Those charged particles, high-speed particles from the sun, even as far away as Pluto is, they still pack a punch, and they will push those atmospheric molecules. They'll hit the surface and make stuff go from ice to gas, and then push it out behind it. They're all the charged particles to some extent, and also the slight trickle of ultraviolet light from the sun will also break some of those molecules apart, and then they'll recombine into more complex organic molecules.
This is, I guess, what we call photochemistry.
Yes.
Yeah, this smog creating.
For better or for worse. In this case, it's all natural. We assume there aren't a lot of automobiles on Pluto, but creating very similar layers of relatively thick by Pluto standards. It's still extremely thin and tenuous compared to Earth. Something like the surface pressure was something like a 10,000th of the
something in the microbar
range, right?
But I think there was the Earth-based measurements seem to be double the New Horizons measurement. So there's some discrepancy.
Right, that'll be very interesting.
Either that or the atmosphere is collapsing.
In just since the last measurements. But in order to address that, not many, but several astronomers here on Earth, including some from my alma mater, just by happy circumstance, 2 weeks before the flyby, there was another one of these stellar occultations, visible only from New Zealand and maybe some slice of Antarctica. So a number of folks traveled down there, set up their high-speed light sensing measurements on telescopes, and watched this star blink out. I haven't heard any results as of yet from those measurements, but that'll provide a very direct comparison between here's what our ground-based techniques tell us, here's what the right next door flyby measurements from New Horizons tell us. They should agree, at least substantially with each other. So it's it's an opportunity to get a cross calibration.
Yeah.
And then we'll know how the New Horizons measurements compare to this whole long history of atmospheric measurements. But yeah, currently it looks like either the atmosphere has thinned out, has gotten colder and essentially condensed onto the surface just in the past couple of years, which we are expecting because Pluto's now on its way further away from the sun. It's getting colder.
So we expect the atmosphere to collapse.
Gradually or suddenly. I'm sure there's some very interesting dynamics going on there. But that will occupy many people over the next several years, I think, chewing on this data. And that's something it's important for us to keep in mind. Even after we get the data in hand, the answers, the interpretation doesn't happen instantly. It takes a lot of hard work, a lot of arguing in conferences about, well, what does this mean, or how does it all fit together? We are being given pieces of a jigsaw puzzle one at a time.
Yeah.
But even when you have all the pieces, it often takes a while to figure out how they all go together.
Let's talk about the colors, because the Pluto does seem to have some reddish. It seems to have some blackish or brownish, and of course something that looks like pristine white areas. So obviously there's some different chemistry there on the surface.
Right, and we can see those colors just with the color camera that's on board. But what I'm, with my own personal bias towards spectroscopy, what I'm keen to hear about is the spectroscopic measurements, the instruments that look at the very detailed color patterns, especially in the ultraviolet, and you can unambiguously, or at least with fairly high certainty, say, oh, this particular patch of this red patch, it's not just red, it's a particular pattern of some reds and not other reds that says that it is acetylene. Acetylene molecules are expected from this photochemistry. And so essentially getting a sense of how the overall, I shouldn't call it an ecosystem because there's no life there that we know of, but the chemical evolution of different parts of the surface is going to keep the scientists busy for many, many years to come.
Yeah. Now the oldest, most cratered parts, the parts below the equator, seem to be blackish. So we assume that some kind of these smoggy particles have been raining out for a very long time, and there's probably a thin layer of organic materials built up.
Some sort of tar. That seems very likely, but we'll have to see if the spectroscopy backs that up. Yeah. It could be some amount of dust, of these tiny little rock particles that have built up over time. If there are craters there, then that's an older surface, so maybe there's been time for dust to accumulate like on our moon. I'm just guessing there, but that's what science is about. You hypothesize and then you test it.
All right. Yeah.
So the flyby was a success. Everyone's excited. The scientists will gradually get their data, but then New Horizons isn't done.
Yes. Tell me about what happens later.
So
it's going to take about 1.5 years to download the data. But there's a whole Kuiper belt out there.
Exactly. That's one of the big realizations of our solar system in the past 30 years is that the formerly 9, now 8 planets are just part of the whole picture. That beyond Neptune and Pluto is this whole belt, this zone of icy bodies. You can think of them as ice asteroids. They're called the Kuiper belt after a planetary scientist who did some work on it. He wasn't the first to suggest that these things might be out here, but the belt was named after him nonetheless. And I think in 1992, the first of these very much smaller objects was discovered, and now there are 1,000 or more that are known, some of which are as big, if not bigger, than Pluto. And that's part of what precipitated this whole debate and the demotion of Pluto to a dwarf planet, when we realized it was simply one of a much larger population of these part ice, part rock bodies. So we'd like to go get a close look at one of these KBOs, Kuiper belt objects. And there are 3 of them that are on roughly the trajectory that New Horizons is currently following. They don't have much fuel. They can't do a big course correction.
Sure.
But they can nudge their direction a little bit in order to get a flyby of one of these KBOs. And that assumes that NASA approves it and that there's continued funding to keep the team going and keep talking to the spacecraft. I mean, the spacecraft's going to keep going no matter what, money or no.
Well, the radio, you know, that little cylinder that sticks out to the side is a, what's called a radio isotope thermal generator.
Right. It's the nuclear battery.
Yeah.
That far away from the sun, solar panels are
won't going to do it. Yeah.
So this is a lump of plutonium that's putting out radiation that gets turned into electricity, but it's gradually ramping down. It's going to run out of.
But I think it's got about 30 years.
It'll keep running for a while, long enough for this extended mission, maybe long enough for New Horizons to reach the boundary of that solar regime, the so-called heliopause. The previous space probes, Voyagers 1 and 2, we think are approaching, maybe even have passed through some layers of this heliopause, but New Horizons went off in a somewhat different direction, so it'll be interesting if it lasts that long to see where that boundary edge of the solar wind is taking place.
There's been some speculation that the heliopause may actually expand and contract, in which case the satellite might
pass through
several times, right. or appear to.
So yeah, we'll be hearing much more about New Horizons as the data comes back, and then when it does its flyby, I forget if it's 2018 or 2019 that it's likely to do that, but that'll be quite interesting in its own right.
It's a good thing the team has a lot of young people. Exactly.
Keep going. They'll be around to see it through to the end.
All right. Thank you so much.
Thank you, Ken.
All right. That was Dr. Bradford Behr, astronomer and optical engineer. Thank you for joining us, and see you next time.